how exactly does an image transfer from server to a client? Let's find out. This is what we think happens in a data transfer. But in reality, it's a little bit complicated than that. First, the server needs to send the image to the R1 router. Therefore, it checks its ARP cache to quickly find the MAC address of R1. If the IP address not found on that table, server initiates and broadcasts an ARP request to find out the MAC address associated with that R1 router. After the R1 router received that ARP request, it first checks if that frame was sent for that R1 router IP address. If so, it reads its data further and ready to send an ARP reply containing its MAC address to the server. Then, the server will update the ARP cache table with the R1's MAC address. Now, let's divide the TCP segment as shown in the screen, including IP headers and TCP headers. We will divide the data, in this case, the image, into 4 segments. Each segment will have a TCP header on top of it. Each TCP segment will be encapsulated into IP packets by adding IP headers in the network layer. Finally, the packets are ready to transfer. The first IP packet will be sent to the R1 router from the server. The server will add a new Ethernet header with the source MAC address of the server and destination MAC address of R1. And the packet will be sent to the destination specified as in the IP header. After the packet received to the R1 router, it will decapsulate the Ethernet header again. The IP packet will continue its journey to go from its source MAC to the destination MAC address, as the header says. In this case, the header's source is changed to R3 router and destination to the R6 router, and push the IP packet to its current destination. You must now familiar with the pattern of changing the MAC addresses of header, source, and destination. This process will continue until the packet reaches to the client from router to a router in its route. The other IP packets will go from a router to a router until it reaches to the client by continuously changing the source and destination MAC addresses when reaching each router. Once the client receives the Ethernet frame, it will extract the payload and look into the TCP segment and arrange the TCP segments in the transport layer using sequence number in each TCP segment. After a limited time of interval, most likely 200 milliseconds, the client will send an acknowledgement to the server, confirming all data packets received successfully. Meanwhile, the client extracts the payload data from the TCP segment for further processing. Finally, the application processes the received data according to its specific logic and requirements.